So if I look at example 6, that's what I'm going to do. I'm going to apply that exponent to every term in my fraction. So I'm going to have 3 squared over p cubed squared all over 7 squared. Well, 3 squared is 9. We take p to the 3rd squared, we multiply exponents, so I get p to the 6th. All over 7 squared is 49. Remember, you're multiplying a number times itself. Don't make that careless error of multiplying by 2, okay? Take the number times itself. Let's take a look at our example here. Well, notice I've got 3 to the 5th over 3 to the 5th. Well, I subtract my exponent, that's 3 to the 0. What the heck is 3 to the 0? Oh, how about this? Look at, these are the same, so I can reduce them. 3 to the 5th divided by 3 to the 5th. If I take a number divided by itself, my answer is 1. So 3 to the 0 must equal 1. And that's what we're going to take a look at in our next example. I'm going to do some powers of 5. I think what I'm going to do is here, I'm going to start with 5 to the 3rd. I'm going to go 5 to the 2nd, 5 to the 1st, 5 to the 0, 5 to the negative 1, 5 to the negative 2, 5 to the negative 3, and 5 to the negative 4. Now let's find those answers. I can use my calculator. 5 cubed is 125. Pull this up a little bit here. There we go. So 5 cubed is 125. 5 squared, well, that's 25. 5 to the 1st, that's 5. And what I want you to notice in this pattern, we're going down an exponent each single time, aren't we? When I go down an exponent, I'm dividing each of these by 5. So I take 125 divided by 5, I get 25. 25 divided by 5, I get 5. 5 divided by 5, I get 1. And I take 1 divided by 5, I get 1/5. I take 1/5 divided by 5. Make this, I'm going to divide that by 5 again, so I get 1 over 25. I take 1/25 divided by 5, I get 1 over 125. I divide by 5 again, I get 1 over 625. So the pattern here is this. 2 things we need to notice. Number 1, anything to the 0 power, I'll call it x. X to the 0 power is 1. Anything to the 0 power is 1. And then notice 5 to the negative 1 is the same thing as 5 to the 1st, except it's the reciprocal. A negative exponent means reciprocal. So if I have x to the negative a, what I'm going to do is I'm going to take the reciprocal of that and say 1 over x to the a power. Or what happens if you just have a plain old fraction? Let's say I've got x over y, and I raise that to the negative a. I'm going to take the reciprocal, so it'll be y over x, and then I'll make the exponent positive. So now it's y to the a over x to the a. A negative exponent does not mean the answer is negative. A negative exponent means your answer is a fraction. Exponents have kind of different rules. So now let's take a look at a couple problems like that and see if what we have to do to figure these out. On this first one, I notice my exponent is 0. I just said anything to the 0 power is 1. It's that simple. The answer is 1. Don't have to do anything else. Anytime you have an exponent of 0, your answer is 1. The only exception is you can't take 0 to the 0 power. Let's take a look at example 9 now. Now, I'm going to subtract my exponents. So 5 minus 3 is 2. So my answer is x squared. Anything to the 0 power is 1. And I'm going to just say my answer then is x squared. Because if you have anything times 1, it's that number, isn't it? We always write our answer with positive exponents. We never leave them with negative exponents or 0 exponents. Let's take a look at example 10. Now here's what I'm going to do. Anytime my exponent is negative, notice I don't have any variables that are the same, so there's nothing to simplify. Anytime my exponent is negative, I'm going to flip it. So n to the 5th, to make it n to the positive 5, I put it in the denominator. P to the 4th, I'm going to leave that in the numerator because it doesn't have a negative exponent. I'm going to flip r to the negative 2. That'll be r squared. And there's our answer. That's all you got to do. So if your exponent is negative, you flip it. Let's take a look at one more here. First, I look at my numbers. Remember, my numbers are different than exponents. So I look at it and I say, oh, 5 goes into 24 times. A positive divided by negative, that's going to be a negative. So I'll say negative, and I'll put it over 4 right now. Now I'll look at my exponents. Negative 3 minus 2, well, that's negative 5. So I'll say r to the negative 5th power. Now look at t. T, 4 minus 7, well, that'll be negative 3. So t to the negative 3 power. And notice I just got a u, and it's negative, so I'm going to put u in the numerator and make it positive. So I get u to the 5th. Now, the answer is negative. We can't do anything about that. Don't change it just because the answer, a negative number is just a negative number. I'm going to flip both my r and my t in the denominator because they're negative. So we get u to the 5th. And then we get 4 r to the 5th t to the 3rd. Sometimes I say this when the exponent is negative, you throw it over the fence to make it positive. That's kind of like the magic part of it, but it's also a nice way to remember it. So anytime the exponent is negative, you flip it and you flip it over the fraction, and then you make it positive.